Every single programmer knows that feeling, right? That sinking feeling when your code just breaks. But what if I told you that moment of frustration could actually become a moment of control? That's what we're going to do in this explainer. We're going to dive in and master Python's error handling, turning those frustrating crashes into super solid professional code.
Oh yeah, we've all been there. You hit run on your script, you're feeling good, and then bam, a giant wall of scary red text just fills up your screen and the whole thing grinds to a halt. It's just the worst. But here's the secret. What if I told you that wall of red text is actually your best friend in disguise?
So what is actually happening here? Well, this is what Python calls an exception. Think of it like this. Your program is chugging along, following instructions, everything's fine, and then something totally out of the blue happens. Python basically throws its hands up in the air and says, "Whoa, I have no idea what to do with this." And that's it. That's what causes that sudden jarring crash.
And this is what you get, this whole mess, the traceback message. I know, it looks super intimidating, right? But it's really just a report card of what went wrong. The real problem isn't the text, it's the crash itself. I mean, an app that just dies on you, that's unreliable, it's a terrible experience for anyone using it, and frankly, it's just not how pros build software.
And that brings us to a really crucial point. Learning to handle errors isn't just about squashing bugs after they happen. Nope. It's about thinking ahead, anticipating problems, and building software that's tough and high quality. Honestly, this is one of the biggest things that separates a beginner from a real pro.
So why should you care so much about this? Well, first off, reliability. Your program actually keeps running, even if it hits a little speed bump. Then there's the user experience. Instead of a scary crash, you can give the user a nice, helpful message like, "Oops, that wasn't a number, try again." And finally, it's about robustness. Your code becomes, well, tough. It can handle weird stuff people throw at it without just crumbling. Okay, so it's time to stop being afraid of that red text. Let's start using it to our advantage. I want you to completely reframe how you see it. It's not a failure notice. Think of it as a super detailed diagnostic report from your code. It's a treasure map that tells you exactly what went wrong, where it went wrong, and why. All right, first thing you'll see, and this is probably the most important piece of info, is the file path and the line number. You can just forget about guesswork. The traceback gives you the exact address of the crime scene. It's like a giant glowing neon sign pointing to the one line in your code that you need to look at. Okay, next up, you're going to look for the error type. This tells you what kind of problem you're dealing with. Python has these specific names for different screw-ups, like ValueError or FileNotFoundError. Knowing the type is like a doctor figuring out if you have a broken bone or a cold. It instantly helps you figure out where to start looking for the cure. And finally, at the very bottom, you get the error message. This is basically a plain English, or plain programmer speak, description of exactly what happened. So here's the pro tip, the big takeaway. You read the traceback from the bottom up. Start with the error message and type, then work your way up to find the line number. Seriously, learning to read these things is the #1 skill for debugging, period. So now we know how to read the diagnostic report after the crash. But how do we stop the crash from ever happening? Well, let's meet our new best friend, our first line of defense, the try except block. I absolutely love this way of thinking about it. A try except block is literally your code's plan B. You're basically telling Python, hey look, I want you to try to run this next bit of code. I know, it's a little risky, and if something goes wrong, that's the except part, I don't want you to panic and crash, I want you to run this backup plan instead. And this slide just shows the magic perfectly. Look at the before on the left. If a user types the word 20 instead of the number, boom, the program crashes with a value error. But look at the after on the right. We just wrap that risky code in a try block. We know a value error might happen, so we catch it with an except block and just print a nice friendly message. The program doesn't die. It just keeps on trucking. It's so much better. Now here's a super important best practice. You have to be specific. Look, it's really tempting to just use a bare except to catch absolutely any error that might happen, but please don't do it. It's a really bad habit. Why? Because you might accidentally catch a totally different bug, a bug you really need to know about, and it'll just swallow it up and hide it from you. Always catch these specific errors you're actually expecting. Okay, enough theory. Theory is great, but let's get practical. Let's see how we can use this awesome try except tool to handle some of the most common errors you are definitely going to run into out there. Okay,
Think of this as your field guide to common Python errors. Trying to turn the word hello into a number, that's going to be a value error. Trying to open a file that doesn't exist, you're looking at a FileNotFoundError. Add a word to a number, type error. Once you start recognizing these patterns, you can get ahead of them. You can wrap your code in the right try except block before it becomes a problem, and your programs will just be so much stronger for it.
So sometimes just catching an error isn't quite enough, right? You need to dig deeper and figure out why it's even happening. For that, we got to put on our detective hats, and I've got a simple, kind of old school, but unbelievably effective trick for you.
It's called the poor man's debugger. And yeah, it sounds basic, and it is, but do not underestimate how powerful this is. All it is just strategically dropping a few print statements into your code. It is one of the fastest, easiest ways to see what your program is actually thinking, step by step.
So how does it actually work? Well, imagine you have a loop that's going through a list of numbers, and it keeps crashing somewhere in the middle. You could just stick a print statement right inside that loop to show you the number it's currently working on. Then you run it, it'll print out 1, 2, 3, 4, and then crash. And you'll know. The last number it printed is your culprit. It's a dead simple way to see exactly what was happening right before everything went wrong.
Okay, so let's wrap this up. What are the key takeaways? First, and most importantly, errors are a totally normal part of programming. Don't panic. Second, that scary red traceback is your friend. It's a map, so learn to read it. Third, try except is your best friend for building programs that can take a punch and not fall over. And finally, remember to be specific with your except blocks. Don't hide problems from your future self.
So now, your code is way more robust. You know how to handle the errors you can see coming. But that brings us to the final, big picture question, doesn't it? What about the errors you didn't expect? The ones that come completely out of left field? How do you build a safety net for those? Well, that's the next step on this journey from fear to total control.